Good afternoon, ladies and gentlemen. Welcome to the group exhibit Hydrogen, Fuel Cells and Batteries. We are here at the Hanover Fairground in the year of 2016. At this moment, I would like to say hello to all our online guests. We are also live streaming from the fair. I invite you all to come and have a seat and enjoy the next discussion. My name is Mona and I will be your moderator for the next 20 minutes. So please come and have a seat, have a coffee. It's all on the house. Our next topic will be the latest trends in battery and fuel cell testing. And for that, our speaker will be from the managing board of FuelCon. So please welcome with me on stage, Mr. Mathias Bode. Big hands, please. Hello. Please have a seat.
Thank you very much for the kind introduction. Good afternoon to everybody. There are still people here. Encouraging.
Yeah. So, we're here today to talk about the latest trends in battery and fuel cell testing. And before we start to dive into the details on testing, could you please give us a brief introduction on what FuelCon is?
What is FuelCon? Good question. We are working in the field of test equipment for fuel cells and battery. This is our main product. Testing. The company generally is not so far away from here located. We are 1 hour by car away from here in Magdeburg. And if you have the opportunity, customers and guests are always welcome to visit our facility. And if you are here in Hanover, you can use the opportunity to pay a visit at FuelCon.
That sounds very nice. So if we visit FuelCon, what are the products that FuelCon is making?
Generally, as already mentioned, test equipment, and we are divided in 3 different product divisions. One is test equipment for PEM fuel cells, polymer electrolyte membrane fuel cells. Second division is focused on solid oxide fuel cell testing, and the third one is focused on battery testing.
Okay, so you test PEM and SOFC in regards with fuel cells. Can you please give us the main difference between those 2 types?
The main difference in this fuel cell types, if we speak about PEM fuel cells, we speak mainly about automotive applications. Everything what has to do with driving a car, with propulsion of a car. And that gives the general operation window of this equipment. It works up to 100 degrees C, about 5 bars pressure, and with typical power ranges up to 250 kilowatt. Speaking about solid oxide fuel cell, then we speak about typically CHP applications for power generation in small houses or in larger areas, maybe power plants, stuff like this. And we speak about high temperatures. We speak about 900 degrees C. We speak about fuels like natural gas, integration of reformers and such things. And from the power range is a little bit smaller. We speak about 5 kilowatt, maximum 10 kilowatt electrical power. Yeah.
So this is the testing. Do you test in Magdeburg, or do you provide testing equipment for the companies? Is that outsourced or insourced?
Typically, the customer operate our test equipment in their own facilities, in a customer laboratory. What we are able to do in our facilities in Magdeburg, we have a full range of hydrogen supply, cooling water, to bring or to start up our test equipment, because we completely build up our test equipment, assemble the test equipment, make a pre-commissioning in our facility, and customer comes to us to check the specification of his test equipment, to see how it works, to get maybe a training on this test equipment. And after this acceptance test in our facility, we ship the test equipment to the customer facility. And
so then it will be on-site. So it will be produced, and then it will be shipped, and then it will be on-site. So for example, in car manufacturing, would that be part of the assembly line?
Unfortunately for PEM test equipment, not at that time. Yeah. When we speak about our third product line, the battery testing, then we speak about integration of test equipment into the final assembling line. We call it EOL, end-of-line testing. And this procedure is necessary for each car battery. Yeah? You can compare this with testing of combustion engines. Typically, combustion engines will be tested at the end of the line. Batteries for e-mobility as well, and this includes a lot of very complex things to test an e-mobility battery, lithium-ion battery, including checking the battery management system, installation of the right state of charge, that the battery will leave the manufacturing line or assembling line with a defined state of charge, checking the cooling loop, the cooling heat exchangers in the battery, checking safety features like isolation control and so on. This is very complex and requires specific test equipment. And this is, at this time, unfortunately, the only part where we have to do in assembling. Yeah? The automotive fuel cell is not so far away from mass manufacturing, but still not at that point that we have significant numbers of produced units.
And in terms of fuel cell testing, is it a yes or no test? Is it works or is it not working? Or what other information can you gather from the testing?
I think, speaking about automotive industry, the testing is a part of each process in the development process. They define different stages of the product development, and each stage requires a validation, qualification, something like this. That starts typically with material evaluation to see, okay, to make benchmarking between different materials, benchmarking between different suppliers of parts. Comes over the testing of subcomponents, balance of plant components like air coolers, like humidifiers, and finally the testing of the complete engine, the complete full working engine with all of the balance of plant equipment to set up the complete control unit. This is what typically engineers are doing in the development process. Set up the control unit with all of the control parameters, threshold values, to finally tune the engine. Yeah.
Let's talk about something that the customer is most interested in. How about the costs around testing?
Testing is not cheap, generally. Mm-hmm. Okay. Generally, we speak about reduction of cost for the fuel cell system itself, but the testing is, I think, a most expensive process in the development, and it's not only the investing into test equipment, because this is you need a budget for this. You invested in a test station, different cell test station or short stack or full stack test station, but the main cost driver is the facility cost and the running cost for gas, for cooling water, electricity, mainly electricity for ventilation systems, for air conditioning systems, and so on. And this requires a high, high cost per working hour of test equipment.
So that would be also an investment for the testing. So in terms of fuel cell testing, the energy that is produced during that process through testing, is there usage for that one?
This is a very good question. Thank you. Speaking about cost means that we are, as a test equipment supplier, responsible to reduce cost, to reduce running cost for laboratory and for facility. And we can do this in different ways. One way is that, especially for higher power demands, we use grid feedback load. That means the electrical energy we attract from the fuel cell, from the stack, or from the complete engine will be fed back into the grid. And this is a very reliable method to save costs. Furthermore, we have equipped our test equipment with a lot of additional stuff to save energy. That includes recuperation of thermal energy, that you don't need to waste too much electricity in the testing, that we have frequency-controlled pumps into our test equipment, that we have a very good adaptation of cooling loops and other things inside on the actual demand of the test equipment.
Okay, and assuming that the hydrogen infrastructure has reached the mass market in Germany, let's say in automotive, and would FuelCon be ready to conclude the test, and in what way will that change the business of FuelCon?
I think generally our main focus is R&D. And if you compare the demand on R&D testing, you can compare a future demand with the actual demand in terms of combustion engine testing. If you see, actually 90% of the testing effort in the car industry has to do with combustion engine, diesel engine, gasoline engine testing, and so on. And we see that this will be our future market. Not typically in the line or something line testing or for mass market. That's why we are an engineering company. 60% of our staff members are engineers, and that gives us different possibilities. We can provide for, let me say, new customers or customers coming new in this field, a standard range of test equipment. Yeah. You can look on our website, you can download data sheets for standard types of cell test, stack test equipment. But on the other hand, with our engineering force, we are able to address all of the needs of customized test equipment. Yes, that means customers come with very, very detailed specifications, including the rules of the different companies, how to design a switching cabinet, how to label all of the wires in the switching cabinet, and so on. And that we are able to address both things, both customers. Yeah.
So the product that you offer is designed for individual usage. So from the beginning on, you look for what is exactly needed in this testing, and then your engineers will design the machinery?
Yes, absolutely. Okay. And that includes our automation system of the test equipment as well, because running a standard engine test for combustion engines is very simple. You need to install a duty cycle, a torque demand or speed demand, and you have to collect torque and maybe temperatures and so on. But testing a fuel cell is a very complex, let me say, adventure, because you collect so many values, temperatures, pressures, gas flows, electric parameters, and our automation system is able to control all of these parameters, to sample all of these parameters, and it can be reduced in the complexity, that it can be a powerful tool for the engineers who can use the full range of possibilities, but with a lot of risk, because you need well-trained people for this. Or we can reduce the degree of freedom to operate our equipment on a very low level, that you have in a very simple realization only in one touch operation, that an operator or a technician can start only a predefined test run. Okay. And everything will run automatically. And this gives us the full flexibility to address a lot of customer needs.
Okay, at this point I can take questions from the audience. Are there any questions from the audience at this time? Okay, I do have a question, and this will already be the last question. So I would like to know why in particular should we test with FuelCon?
I think at first we do this since 15 years, since the beginning when fuel cell come in the focus of people. That means we are pioneers in this field. We focused only on fuel cell and battery testing. That gives us a very deep understanding of what customer need to test, what customer want to test, and what kind of data he want to attract from the test station. Because with our equipment, with our machinery, we only create costs. The only value we create is data. And we are the company who can keep this data as a very safe and as a very valuable result of our test equipment.
Okay. So will we see you here at the next fair in 2017?
I think, of course, yes. Yeah. We are a little bit pioneers. I think we joined this group exhibition since more than 10 years. And if you want to visit our booth, you find us straight ahead. Booth number C64, directly in front of the forum area.
Yeah. Thank you very much for this interesting presentations. All other questions can be taken to the booth. Once again, it is C64. I would like to thank you. That was Mathias Bode from the managing board of FuelCon. Thank you very much. Yeah, sehr gut. That was our last presentation for today. We are closing the public forum here at the Hanover Fair at the Hydrogen Fuel Cell and Batteries Group exhibition. I wish you had a really nice presentation, that you enjoyed the public forum, and I would like to thank you all.